Alright, this is example 4.2.5. This is a bomber drops a bomb at an altitude of 5,200 meters. Determine the horizontal range the bomb will fly if the plane was traveling 100 meters per second when the bomb is launched. So, the first thing we were trying to do is we were trying to solve for the horizontal range, which is the displacement in the x direction. Okay, since we know this is a two-dimensional question, we know that in the x direction we can use the formula v equals delta d over t, and we know in the y direction we're going to use if that. So we have a bomb that's being dropped from an airplane. That bomb is 5,200 meters above the surface of the earth, and it is traveling initially at 100 meters per second in the horizontal direction. Now that's what the plane is doing, but the bomb at the time of the drop is actually part of the plane. So if the plane's moving at 100 meters per second, so is the bomb. So it will take a path, something like that, and you were trying to figure out what the distance is that it travels. So our given information, we're going to separate it into x's and y's, and we know that in the x direction that its velocity is 100 meters per second, and that's really all we've got. In the y direction, we know that the altitude, the distance in the y direction, is negative 5,200 meters. Now once again it's negative because over here that the bomb is going to drop or fall that far. We know the acceleration is negative 9.8 meters per second squared, and we know the initial velocity is 0 because it was flying horizontally to begin with, or there was no indication of any sort of vertical velocity at all. So because of this, I'm going to say, okay, well, I'm going to solve for time, and how I'm going to do that is I'm going to do it with the y direction because I have enough information to do that, so that I can then cross it over into the x. So I've got initial velocity, distance, acceleration, trying to solve for time. So the equation that doesn't have final velocity is once again delta d equals vit plus 1/2 at squared. Now remember, since the initial velocity is 0, that term's going to cancel out, and so what I'm going to get is delta d is going to be equal to 1/2 at squared. You should be familiar with this rearrangement already. We've gone over it several times. So to isolate this for t, it becomes 2 delta d over a square root equals t. If you can't go from here to here, you need to review previous examples because you've got to be able to do this algebraic manipulation. So once you're here, you can go ahead and plug in your numbers and you can solve for the time. You can say that the square root of 2 times negative 5,200 divided by negative 9.8, all under the square root sign. You go ahead and put it in your calculator, say 2 times negative 5,200 divided by negative 9.8, take the square root of that value, and you get something around 32.6 seconds. Remember that 32.6 seconds crosses over into the x direction, so now you can apply it there. So in the x direction, remember this is the only equation I use in the x direction, is v equals delta d over t, or delta d equals v times t. Now I have the time and I have the velocity, so I plug those values in, and you get 3260 meters.